Hi guys, welcome to Momentum with Vedantu. Welcome to this very special session of Momentum with Vedantu, guys, where we are going to talk about top 10 facts revolving around Big Bang. Okay, Big Bang is a very mysterious very mysterious thing, guys. First of all, many scientists doesn't want to call it Big Bang. It's just so many confusions here. So many people disagreeing with each other. Einstein himself did not believe in Big Bang, so many things happening. Okay, so let's talk about it. Let's exactly see what it was. First of all, guys, we need to understand that. First, let's look at the quote from Stephen Hawking. Stephen Hawking said that if the rate of expansion once again after the Big Bang had been smaller even by one part in 100,000 million, it would have recollapsed before it reached its present size. On the other hand, if it had been greater by a part in a million, the universe would have expanded too rapidly for the stars and planet to form. What he meant here is, guys, that it was a very delicate process and it had to happen just the way it happened for us to exist. Otherwise, things would have been so different right now. We have no idea how it could happen. Okay, so it's like a cosmic butterfly effect. It had to happen that way. Only then things would be the way they are right now. Otherwise, things would have been very different. Either there would have been the universe would have collapsed too fast, or it would have expanded too fast. It would not have expanded the way it is expanding right now. Okay. Also, so first of all, where does it start? Where does all these things begin? Okay. So first thing that happened is that Einstein gave his theory. Okay. Where is that? Yeah. Einstein gave his theory. Where is it? Where is it? Where is it? Yeah. Einstein gave his theory called uh, the general theory of relativity. Okay, and general theory of relativity was superb, guys, because it said a lot of things right. Okay, so I think everybody is aware of something called Newton's law of gravitation. F is equal to gm1 m2 by r square. Turns out it's not always correct. Okay, it's correct for a very it's a correct for range of masses, but if you have very heavy masses very close to each other, then that formula is not very correct. Okay, and that was a big problem because if you use Newton's formula, F is equal to gm1 m2 by r square, the orbit of Mercury, the orbital radius, the time period, and everything comes out not according to the calculations. Okay, not according to the observations, and the calculations were not matching if you use Newton's law of gravitation. So, in response to that, Einstein came up with general theory of relativity, and it had some very bold ideas. One of which is given in this paper only. If you see this photo here, guys, what is happening here is, if you look at this photo, what exactly is happening here? It's basically talking about how the actual position of the star would look to us shifted because the light is bending around the sun. It is the actual position of the star will look to us shifted because the light is bending around the sun. That was one of the things that Newton's law of gravitation said, that light will bend around very heavy objects. Okay, that was the bold thing he said. And when we did measure it using our telescopes, it turned out to be true. Okay, but also at the same time, Einstein's general theory of relativity predicted something else, which was problematic. Okay, what else did it predict? Else exactly it predicted? So the problem is that if you assume Einstein's general theory of relativity, then the universe would not be a static place. Okay, a static universe would inherently be unstable. So in that universe, in Einstein's universe, if you consider general theory of relativity correct, things should either go away from each other or they should move towards each other. Okay, and what happened is that essentially what we found out later was that things are actually moving away from each other. Okay, galaxies are moving away from each other, stars are moving away from each other, all those things are happening. Okay, so that is one of the key things that came out of that. Okay, now why is that problematic? Because then if the universe is expanding, we need to know why the universe is expanding. And when somebody tried to answer that question, that's when the idea of Big Bang came into picture. Okay, so there was this guy called Lemaitre. Okay, or Lemaitre, I can't pronounce his name. Okay, he was a Belgian guy, and he basically for the first time proposed this idea that the space itself is expanding. The universe is expanding because the space in the universe is expanding. Okay, and this idea, he backed it up with a lot of calculations. And when Einstein saw that paper, he himself hated it. Einstein hated the idea of space expanding at that point of time. Okay, and he hated the idea that that means that universe might have started from something called a Big Bang. Okay, he hated it as a possibility. Okay, but what happened is that Lemaitre proposed this idea in 1927. Einstein dismissed it, whatever. But some things happened that it could not no longer be ignored. Okay, what exactly happened? Hubble's discovery. Okay, basically Hubble actually discovered through observations that the universe is expanding. Okay, what exactly? How did exactly did he observe that? So basically, guys, I don't know if you guys have heard Doppler effect. If you guys have heard Doppler effect, so what you see is if things are coming towards each other, the frequency of those if a sound source is coming towards you, the frequency seems a little bit increased, and similarly if a sound source is going away from you, the frequency seems a little bit decreased. Okay, same thing also happens with light. Okay, same thing also happens with light. And what Hubble discovered is that the galaxies which are farther away from us, they are showing this red shift. Basically they are moving away from each other. That was a confirmed experimental proof for that. Okay, and that means that the universe was expanding. That was the first time that people took this idea seriously. That was the first time when people took this idea seriously. I hope everybody is following this. Okay, but thing is, the first time it was proposed by was by some guy named Friedman. Okay, and in 1927 it was again reiterated by this Lemaitre. Okay, and again Hubble discovered his expanding universe in 1929. But still, decades after that, that idea was kept, the scientific community just kept dismissing that idea. Okay, because the idea that the universe might be expanding was just too much new at that point of time. Everybody just assumed that this universe was a very static place, and that all the things are just the way they are. Okay, and everybody just assumed that there is no starting point of universe in time. Okay, anyways, now finally what happened is that uh, in 1940s is the first time this theory rose to prominence. Okay, in 1940s, the first time. Okay, why? Because there was this guy who was obsessed he's an American scientist. First of all, so many names I forget names. Okay, but he was obsessed with the idea that Lamarck said, that if the universe is expanding right now, and which it was, it must have started from a point. There must be a time in the past, a certain time in the past, where it just started. And that idea, as crazy as it sounded to the scientific community, to many people, we are always looking for explanations, right? How things came into existence. So that idea was the first time where anybody talked about how the universe itself came into existence, and it was very novel, and people actually started taking it seriously. Okay, and this guy did a lot of calculations. He went back into time, and he modeled how high the temperature was. And what he realized is that as you keep on going back in time, there must have been a time in the past when the universe was so small and so hot that there was no way there would have been any atoms. Okay, the electrons and protons would just fly off in different directions, and there would not be any atoms. Okay, and if you go even back further back in time, the universe would have been even hotter, and at that point of time there would not be even nucleus, because just the universe is so hot. That that state of the universe, he named it the primordial egg. Okay, for at that point of time nobody was using the name Big Bang yet. He named that state where the universe was just a giant ball which is so high temperature that there are no nuclei, there are no atoms, nothing. It's just everything is just super high temperature. He called that state primordial egg. Okay, actually Lamarck named it primordial egg, but he just क्या बोलते हैं, he went along with that idea. Okay, and then the famous name came into picture by this guy named Fred Hoyle. Okay, Fred Hoyle was a British scientist, and he was just fervently opposed to this idea that the universe started with a big bang. Okay, and he went on a radio show and he tried to make it relatable to people, and that is how it started. He tried to make it relatable to people, and on that radio show, to give an idea of what people were trying to say, he gave this phenomenon a name of Big Bang. And from that point on, the name Big Bang has got on. Okay, so the actual naming of the Big Bang was done by a guy who did not believe in it at all. Who did not believe in it at all. Okay, now the conclusive proof of Big Bang came in 1964. Okay, and that was done by these two guys. Once again, very weird names: Arno Penzias and Bob Wilson. Okay, very weird names. So they were collecting data using some antenna. They were basically analyzing electromagnetic waves. Okay, antenna data, electromagnetic waves. They were collecting data, and what they realized is that if from everywhere in the sky, okay, the antenna is picking up some kind of microwave radiation. Okay, and the thing is, that microwave radiation should not have been there, but it was there. And so they thought that their equipment was malfunctioning. And they tried to calibrate that equipment and do whatever they could, but the radiation would not go away. The microwave radiation that the antenna was capturing would not go away. It was there. So they thought something wrong with the antenna. They went to the antenna, and actually it turns out there was a pigeon there who had made a nest. Okay, so they cleaned it out, thinking that the bird poop was causing the wrong data. They cleaned it out. Okay, they actually, two scientists cleaned out the bird poop, and still the microwave radiation was getting captured. As it turns out, this microwave radiation, which was being captured, which was there everywhere in the sky, is what is called the leftover glow from the Big Bang. They had discovered the leftover glow from the Big Bang. Okay, in the beginning, the universe was very, just after the Big Bang, the universe was very, very hot. There was a lot of radiation. Now, as the universe has cooled down and as the space has expanded, that radiation is from a very cold temperature source. So that radiation is in the microwave range. Okay, but it was created right at the Big Bang. It is the leftover glow from the Big Bang. Okay, these scientists discovered it, but they couldn't believe themselves, so they just thought it was caused by bird. Okay, by the way, because of this discovery, they did get Nobel Prize, and it was mentioned in the speech that we got Nobel Prize, and our scientific contribution for this is we contributed to science by cleaning up bird. Okay, they got Nobel Prize because they decided to clean up bird poop. Otherwise, they wouldn't have been taken seriously. So yeah, and that's also what happened. Now, the thing is, once the Big Bang was confirmed, now we can talk about the explicit history of formation of stars and galaxies and planets in the universe. Okay, and when we do the calculations, we realize that after the Big Bang, things were very, very hot and things were just moving far away from each other. But after a while, things started cooling down, and that is when we had the first stars. Okay, if you look at this diagram that was given right in the beginning, okay, the first stars came the first stars came somewhere around the 400 million year mark. Okay, and exactly 50 to 100 million years later, the first galaxies came into play. Okay, the universe was still very, very hot. This is the Big Bang. This is where after 400 million years the stars started getting formed. In between, the universe was just getting expanded because just the temperatures were still very high. Okay, now uh, at the if you do all the calculations all the way back, we have 13.77 billion years. This is approximately the timeline of how farther back away in time the Big Bang happened. Okay, 13.77 billion years. That's a long period of time. That's a long period of time. Okay, now next is, yeah, this is the afterglow right after the Big Bang. This is how it should look like. Okay, next, the fluctuations in the cosmic microverse background tells us how close to perfectly uniform the universe was at the start of the Big Bang. I don't even see. What happens is in the beginning things were very uniform. Okay, things were very uniform. Have you seen a piece of uh, pure gold? Pure gold. Book. All the atoms in there are pure, just gold atoms. That's a very uniform. That's a very uniform object. Similarly, in the beginning of the universe, everything was close to perfectly uniform. Okay, but how different it was, how much non-uniformity there was, we can measure it today by measuring the fluctuations in the microwave, the leftover glow, the microwave, the cosmic background microwave. If we see the fluctuations in that, we can see how much non-uniformity was there in the Big Bang. Okay, so guys, we are talking about something that happened 13.7 billion years ago, and the evidence of how it was is still there today. Okay, it was a big event. It is the reason why you are still there. It is the reason why you are still there. Okay, now the last thing, the second last thing, the Big Bang doesn't necessarily mean the very beginning anymore. So when Lemaitre put forward his idea in 1927 that Big Bang is basically, he called it the primordial egg, but whatever, that is the beginning of the universe. Nobody took him seriously, and but at some point people started taking him very seriously. But the recent calculations and everything, they tell us basically that it might not have been the actual beginning of the universe. The universe might have existed before that as well. Okay, but but we are not sure because whatever it was before it, we don't have much evidence of what is remaining right now. And most of the things are like the evidence of what was is not present right now. So we don't know how the universe was before the Big Bang. But it doesn't mean that there was nothing there. Okay, it's just a hypothesis. We don't know for sure. Okay, and finally, I guess everybody can see this. This is our actual universe right now, guys. This is our actual universe right now, and I don't know if you guys understand what this means. Basically, this is our universe starting at the Big Bang, and as the time progresses, the universe is expanding, and it is expanding at an accelerating rate. Okay, it might have expanded and contracted, it might have expanded and then decelerated the expansion, it might have expanded at a uniform rate, but no, it is basically expanding at an accelerating rate. Okay, now this was once again confirmed very recently that our universe is expanding at an accelerating rate. Okay, we discovered something around 18 years ago called dark matter. Okay, not dark matter, dark energy. Okay, and because of dark energy, the existence of dark energy basically tells us that universe is expanding. Why is universe expanding? Because of dark energy. What exactly, how exactly is it doing that? Don't ask me. Okay, but up until 18 years ago, we did not know this, that how the universe will end actually. Okay, and because there is no evidence of it present in the when we look at the Big Bang, we can't actually figure out how it will, in which direction will it go. We actually did not know up until a very few years ago how it will go. It will be a decelerating universe, or will it be an accelerating universe, or will it just do fun? Okay, now we know after this debate now is put to rest after the after the discovery of dark energy. That dark energy tells us that the universe is expanding, it is expanding at an accelerating rate, and the galaxies which are farther away from us, they are moving much faster away from us compared to the galaxy which are nearby to us. Okay, so things which are farther away are going away from us even faster than we imagine. That is what is happening, guys. Thank you so much for coming to this lecture. This was a very special Vedantu lecture. We were just going to talk about the 10 essential interesting facts about the Big Bang. If you have any doubts, guys, you can write them in the comment section. I will try to answer them. Or if you want to ask me questions personally, you can ask me questions personally on my telegram. You can write me your doubts at AADITYAP 832. All right, guys, thank you so much, thank you so much, thank you so much, thank you so much for watching this video. If you haven't liked, share or subscribe to our channel, please do that, and I will see you guys next time. Okay, bye.